So, for you people that love Excel, here you go. This is the video that you've all been waiting for all year long, right? So this is the EDTA titration, and this is the Excel spreadsheet that you might see with the EDTA. So, depending on how much involved we want you to get with the EDTA titration, you could leave some of these sections out, or you might have to expand on some of these sections. So let's just take a few minutes and take a look at what is showing up on my computer screen and what you should be doing as far as the spreadsheet is concerned. So up here at the top, you're going to see that there's a part A listed, and this is called titrating the blank. So the blank is basically DI water. DI water should not have any ions associated with it. It should just be water, and that is it, H2O. Well, we're going to find out that water could actually give us a false read. And this water that we are referring to as the DI blank or distilled water blank should be really close to 0. So if you look at this person's spreadsheet, they're going to have the initial reading and the final reading and the volume of EDTA, which is 3.8. So it took 3.8 milliliters of EDTA to get that color change to happen from pink to blue. Now, you're probably scratching your head thinking, well, why? Why would it even do that, right? I mean, this is DI water. Why should that go on? Well, this is stuff that's dealing with the buffers and the indicators and the DI water and the EDTA, and sometimes it just takes things a couple of milliliters in order to go from one color to the next. So that's the purpose of the blank. It's like blanking out anything. You blank out the balance, don't you? You have to blank out the titrant. You've got to figure out what DI would normally read under these circumstances using these solutions that were provided to me, made by someone else. So that's what this person did, and the average volume of EDTA was averaged here and reported. Now, maybe we've done this for you, and maybe we won't even mention this in the laboratory. You will just start titrating samples, and if so, then that's great. This is less titrations that you have to do. But ideally, you should be pipetting and you should be titrating a blank 50 milliliters of DI water. Okay, for part B, it says titrating the hard water sample. So depending on the year, we will probably give you a sample that we know the concentration of. We know how much calcium and magnesium is in that solution. So we're going to give this sample to you, and you're going to titrate the sample, and you're going to report that number back to us, and that way we know if you're doing the titration the proper way. Well, depending on the year, we might give you two of them. We might give you what we call a hard water sample and a soft water sample. One will take more milliliters of titrant to titrate than the other. But we will know the concentrations of all of these. So you will titrate these first, and then you will report back what those concentrations are, or how many milliliters that you've taken to titrate them. And this will give us an idea of whether or not you're on par. Are you performing the titration the right way, yes or no? Okay, so the way that we do this is that we do it just like the blank, the initial reading and the final reading. So it started off being 19.2 or backward, 30.85. And then we subtract those two numbers. And this gives me the volume of EDTA that it took to titrate. Well, the volume of EDTA for the blank was 3.63. Again, maybe we don't want you to do a blank that year. If so, you put a 0 here because you didn't do one. You assume that it's 0. So the difference between my sample and the blank is the actual amount of milliliters that it took to titrate that sample that did have calcium in it. So that's the volume of EDTA. Well, I do that round 1, and I do that round 2, and I do that round 3, and I get a different volume on each one, and then I take those 3 and I average them up, and I get 7.49. This is the average amount of EDTA that it took in terms of milliliters. Okay, so I know the milliliters of EDTA that it took. And the molarity of EDTA is going to be given to me. Right here it is, 0.094, right there. Okay, well 0.0094 is my molarity. I multiply that like we did in a previous video by the milliliters of sample that it took in liter, 0.00749. And then I hit enter, and that gives me the moles of EDTA. So J5 molarity times parentheses D19, which is my volume, divided by 1,000, because that's in milliliter. I need to convert it to a liter. And then I hit enter. Well, that moles of EDTA is also the same exact moles of calcium carbonate. So the only thing that I have to do here is hit enter and then click on that cell. So whatever number shows there will also show up here, and that calculation's now done. The sample size, how many milliliters of sample did I use? The lab directions are going to tell me 50 milliliters. So I'll type in 50 here. So if I know the moles of calcium carbonate, and I know the sample size in milliliters of calcium carbonate, I can calculate molarity just like what we did before in the previous screen. To calculate molarity, I take moles divided by 0.050, because this is milliliter and I need to convert it to a liter. So that's how I calculate the molarity of calcium carbonate. If I wanted to obtain the part per million calcium carbonate, then this is mole per liter. I need to change that to milligram per liter. So what you're going to see me do is that I take the molarity, which is here, and that's moles per liter. Well, I'm going to multiply by the formula weight of calcium carbonate, which is 100.19, give or take. Calcium's 40, plus carbon, which is 12, plus oxygen, which is 16 times 3. And then I'm going to multiply by 1,000, because that is gram, and I need to convert to milligram. So gram to milligram, I need to multiply by 1,000 in order to do that. Then I hit enter, and I get around 141. Okay, so that is how I calculate the ppm of calcium carbonate in my sample. And again, if you watch the previous video, you will see that in that video I kept referring to just calcium only, and that was a mistake. That needed to be calcium carbonate. So I multiplied by 40, which was just calcium, and we need it to multiply by the calcium carbonate formula weight, which is 100.1-ish. Okay, part C is titrating tap water. Maybe we didn't use tap water. Maybe we used a soft sample instead that one of us had made. If so, that's where those numbers go. You treat them just like before. And then you might have a part D, and part D will be the water study. So with part D, you will have a sample number, maybe number 68. And you will titrate that once or twice or 3 times, and you will record the volume that it took. And then you will go through this process all over again. So in order to do that, what I would recommend you to do is do sample number 68, 69, 70, 71, 72, 73, and so forth. And then just go through and make some columns. This is how many milliliters that I started with. So milliliters initial. This is how many milliliters I ended up with. So this is the milliliters that it took. So what was it before and what is it after? Do that subtraction, right? Well, I know the EDTA concentration, so I can calculate the moles of EDTA. And if I know that one, I know the moles of my calcium carbonate, so I'm going to put C-carb there. And I know the sample size, 50 milliliters. And then here I can put molarity, and here I can put ppm values. And the only thing that I have to do is just go through and copy all of those equations that I've done up there here. And if you did this more than once, do 68A, 68B, 68C, and just so on, and just average them up at the very end. But this is the way that I would do it as far as the table and the spreadsheet goes. Just make you individual columns and have each row basically be a sample size. So basically, you're doing the same exact thing that you're doing here, except you're laying it out in a different way that is more user-friendly when you talk about multiple samples, especially if you're titrating 20 or 30 of them. So that's how we do the EDTA titration. What you need to do as far as turning in the lab, you need to make a spreadsheet that's similar to this that represents all of the work that you've done, and you need to clearly show the part per millions of maybe your hard water sample, your soft water sample, the water samples that were submitted, who knows, but you need to clearly show those. All right, so that's it of EDTA. Good luck on the spreadsheet. Good luck on all those calculations, and remember, the previous video had a mistake. You should be using calcium carbonate formula weight, not calcium formula weight.